Hey, good evening, welcome to
MinuteMath124.
MinuteMath number 124, special double Minute Math day.
Yeah.
That's awesome. Okay, so this is actually a neat little geometry problem, but unfortunately we haven't really talked too much about volume, so I'll help you through it and hopefully we'll learn a lot. Okay?
Yeah.
An aquarium has a rectangular base measuring 100 centimeters by 40 centimeters, and it's 50 centimeters tall.
It's pretty small.
Well, that'd be big for a fish tank, I bet. A meter long. It's bigger than our fish tank. It is filled with water to a depth of 37 centimeters. A rock with volume 1,000 centimeters cubed is then placed in the aquarium and completely submerged. By how many centimeters does the water level rise? Ooh, pretty cool. Well, what would you think? What do you think is the first thing to do on this problem?
Draw a picture.
Okay. So we got sort of a rectangular fish tank. It's, what is it, 40 centimeters wide? 50, or it's not 50, 100 centimeters long. And how tall is it?
It's 50 tall.
50 tall, okay.
And it's filled up to 37
All right.
centimeters.
Can you grab one of those blue? Okay. All right, so here's our water, sort of we fill it up to 37 centimeters, so.
And then we put a rock in.
Yeah. Now what do you think is going to happen when you put the rock in?
The water level is going to rise some.
The water level is going to rise some, and the question is how much is it going to rise? Now how do you think we're going to figure that out? Do we know anything about the rock?
Yep. All we know is that it's 1,000 cubic centimeters.
Ah, and we also know it's completely submerged when you put it in. Okay. So when we put this rock in, the water level goes up a little bit. We're trying to figure out by how much. So what do you notice in the picture, or what can you imagine in the picture from where the water used to be to where it is now? What does that look like in the tank?
It looks like it didn't rise a lot.
Didn't rise a lot. What shape is that it looks like?
Should I read both of these lines?
No, the old water to up to the new water. What sort of shape is that?
A rectangle all the way around.
Sort of looks like a rectangle all the way around, but it's a thick rectangle. So maybe it's kind of a thin pancake rectangle. What do you think is important about that rectangle?
Well, we can figure out the length and the width.
Okay. What is the length and the width of that rectangle?
The length is 40 and the width is 100.
The length is 40. The width is 100, and we have to figure out how tall it is, that sort of three-dimensional rectangle. Now, do we know anything else about this little box?
Well, it's bigger than this area.
Yeah, volume. The volume.
Yeah, the volume's pretty small.
It's interesting. What is the volume of this amount of water? When we put the rock in, the water level rises up by some volume. How much volume do you think is in this new water?
Well, we took away 1,000 cubic centimeters from the water, so it has to rise that much.
It has to rise up by exactly the volume of what we put in. And you said it actually in a pretty interesting way. We took the water away where the rock is. So that water had to go somewhere, right? And it just rose up. So we have the volume of this box, the new box of water, has to be 1,000. So how do you figure out what the volume of this new box is?
100 times 40 times x.
100 times 40 times x equals
1,000.
1,000. Okay?
Well, it's 400 times x is 1,000.
Well, what would be even easier, actually, than multiplying 100 times the 40?
We could we could cancel the zeros. So.
Which is the same as dividing by 100, right?
Mm-hmm.
So if I divide this side by 100, this goes away. If I divide this side by 100, what do I get?
You get 40x is 10.
40x equals 10, or in other words, x equals?
X is 1/4.
1/4. What are the units of that? 1/4 of what?
It's a fourth of the tank. No, it's not.
A fourth. What are our units in this problem?
Centimeters.
Centimeters. So 1/4 of a centimeter. So it doesn't rise up that much. That rock isn't too big compared to the tank. It rises up 1/4 of a centimeter. What is that in decimal, by the way? What's a fourth
It's
in decimal?
0.25.
0.25. So this is a pretty neat geometry problem. You know a famous story about somebody putting a gold crown in a tank of water and measuring its
Yeah,
volume?
Archimedes.
Archimedes. That's how we did it. Pretty cool problem, right?
Yeah.
I like this problem. It's a fun way to learn a little bit about boxes.